The planet is heating up. Global temperature records are shattering year after year. The consensus is clear: humanity must drastically cut carbon emissions. But what if we fail? What if the crisis accelerates faster than our ability to adapt? Enter geoengineering, the radical, intentional, large-scale manipulation of the Earth's climate system. To its proponents, it's a necessary emergency brake, a last-ditch tool to buy us time. But to its critics, it's a perilous techno-fix that poses an unprecedented global gamble. It doesn't solve the core problem of carbon pollution, it simply masks the fever. Today, we're peeling back the layers on this controversial topic. We're not just exploring the science fiction of solar shields and artificial volcanoes, but diving deep into the unforeseen economic disruptions and catastrophic climate risks that come with trying to play God with our planet. Geoengineering is typically split into two broad categories. The first, and most expensive, is carbon dioxide removal, or CDR. This is essentially cleaning up the mess we've already made. CDR technologies, like direct air capture, DAC, giant vacuum cleaners sucking CO2 from the air, or enhanced weathering, which accelerates natural rock erosion to absorb carbon, are generally seen as less controversial. Why? Because they tackle the root cause, the concentration of greenhouse gases. However, they are currently immensely expensive and require colossal amounts of land and energy. The economic disruption of geoengineering is speculative. The climate disruption is a certainty, though its exact nature is unpredictable. SRM is not a simple, clean undo button. It's a crude planetary thermostat. Unlike any thermostat, it can only control the global average temperature, not the complex, interconnected weather patterns that underpin civilization. The most significant and terrifying risk is the disruption of global precipitation patterns. Models show that while SRM can cool the planet back to pre-industrial temperatures, it would also likely reduce global precipitation. For some regions, this means a shift in the crucial monsoon cycles that billions of people rely on for agriculture and water security. One analysis suggests that manipulating the climate could result in widespread drought and flooding in diverse areas, triggering property losses and massive agricultural failures. Imagine a scenario where a country that implements geoengineering is immediately blamed by a neighboring nation for a disastrous drought. This leads us to the most dangerous climate and economic threat of all: termination shock. Stratospheric aerosols need to be continually replenished, typically every 1 to 2 years. If, for any reason, be it a war, a massive economic collapse, or a sudden realization of unacceptable side effects, the deployment is abruptly stopped, the planetary cooling effect would vanish almost instantly. The vast store of unmitigated greenhouse gases would then take effect. Temperatures would rebound at a rate unprecedented in modern human societies, potentially spiking by several degrees Celsius in just a few years. The resulting economic damages from this rapid, catastrophic warming, droughts, mass crop failures, and mass migrations, would likely dominate the entire cost-benefit analysis, rendering any perceived short-term savings completely meaningless. Perhaps the hardest problem of all is not scientific or economic, but political. Who gets to decide the Earth's thermostat setting? Because of the low cost of deployment, SRM could be launched by a single wealthy country, or even a non-state actor, a technological capability dubbed the gamble of the globe. This scenario shatters the decades-long push for collective international climate action, replacing it with a unilateral technical maneuver. Climate models show that SRM would not cool the planet uniformly. Some nations might experience an optimal climate, making them winners, while others might face severe drought or excessive cooling, making them losers. This potential for uneven, geographically diverse impacts is a powder keg for geopolitical tensions. Experts warn that this could lead to cross-border conflicts and the potential for a military or geopolitical use of the technology. We are currently without any comprehensive, legally binding international governance framework to regulate geoengineering. The existing framework is fragmented, relying on state cooperation that is already strained by the current crisis. The very act of deploying geoengineering without global consensus is an act of planetary modification that risks undermining global peace, security, and cooperation. It weaponizes the weather, turning climate parameters into bargaining chips. The economic story is complex. While SRM presents a moral hazard to the global decarbonization effort, the underlying rationale for it is often framed as a humanitarian necessity. Some studies project that a geoengineered cooling of the planet could offer the largest economic benefits to countries in the tropics, historically hotter and poorer nations, where rising temperatures have the most crippling effect on GDP growth. For some tropical developing countries, incomes could increase by well over 100% over a century, compared to a more moderate increase for wealthier, temperate nations like the US. The argument is that geoengineering could potentially reduce inter-country income inequality by slowing the economic damage being disproportionately inflicted on the global south by climate change. But this is a double-edged sword. The same research underscores that a robust system of global governance is essential to ensure deployment is made for collective benefit, not just by one powerful actor. The risk is that the poorest nations, who stand to gain the most from avoided climate damage, are also the least equipped to deal with the unforeseen side effects of the geoengineering itself, or the devastating consequences of a termination shock. The economic trade-off, therefore, is stark. Potential upside: avoided climate damages, reduced global income inequality from warming. Potential downside: catastrophic economic loss from precipitation failure, agricultural collapse, and irreversible damage from a termination shock, all compounded by a diversion of funds from proven mitigation strategies. Geoengineering, particularly solar radiation management, is the embodiment of a risky gamble. It's a high-stakes, planetary intervention that treats a symptom, rising temperature, while ignoring the disease, atmospheric CO2 concentration. The scientific and economic consensus today is not that we should deploy geoengineering, but that we must treat it with extreme caution. The risks of moral hazard, of precipitation disruption, of termination shock, and of geopolitical conflict are simply too great, too unpredictable, and too difficult to govern. The research into geoengineering must continue, but with the primary goal of better identifying and mitigating its uncertainties. It should never be seen as an alternative to the fundamental work of mitigation, cutting emissions now. Effective climate action is already technically and socially feasible. We can't bet the future on a hyper-modern, techno-fix that could destabilize the very systems it is meant to protect. The only way to truly win this climate fight is to turn off the carbon faucet, not just try to shade the spill.